Here we are, week 19, Pure Maths 1 maintenance. First question is a quadratics question, finding the real values of x that satisfy the following equation. I'm going to say, I think it should be this. Okay, I'm going to say let y equal x squared, and I can rewrite that whole equation as y squared minus 13y plus 36 equals 0. And then I can factorize that, so I'm thinking y minus 9 bracket y minus 4 equals 0. And so y equals 4 or 9. Therefore, x is equal to plus or minus the square root of 4, or plus or minus the square root of 9, which is plus or minus 2, or plus or minus 3. The next question is a functions question. We've got to find an expression for the inverse. I would just write it out like y equals x squared minus 2 first. Then I'll just switch across my x and y's, which is what we're doing in an inverse. I'm going to rearrange, so I get y squared equals x plus 2. And so y equals plus or minus the square root of x plus 2. Now, given that we're looking at x is less than or equal to 0, if we were to sketch this x squared minus 2, it looks like this, and they're defining the function for this side of the equation, which of course means that when we are putting in our value here, we want minus the square root of x plus 2. Now, the coordinate geometry question is next. We're trying to find the equation of MB and the coordinates of B. Okay, the midpoint of AC. Okay, so let's find M. M is the midpoint of AB, AC. So we go minus 3 plus 5, and we divide that by 2 to find the average of the x values. And we're going to do the same for the y values of A and C. And so this gives us that M is actually got a coordinate of 1, 4. And we know that M, the perpendicular bisector, cuts the x-axis of B. Okay. Okay, so we want to find the gradient of AC first. And so let's change in y, so 6 minus 2, so I'm going C, take away A here, and then go over the x, which is 5, minus 3, which I think is 4 over 8, or 1/2. So therefore, the gradient of the perpendicular, MB, is equal to -2, because it's the negative reciprocal. And at this point now I can find the so line MB is going to be y minus, and I've got a coordinate for M here, y minus y1 equals M, so is the gradient of the perpendicular, into x minus x1, so I'm using that coordinate for M there. I'm just going to rearrange this. I get -2x plus 2 plus 4, or y is equal to -2x plus 6. And the last bit is cuts the x-axis at B. Now, it cuts x-axis when y equals 0. Therefore, 0 equals -2x plus 6, and you can clearly see that 2x equals 6, therefore x equals 3. So the coordinates of B are 3, 0. Okay, show that AB is perpendicular to BC. Okay, the gradient of AB is equal to, now, where's my B? Okay, 3, 0. So I'm looking now at AB, so this one and this one. So I'm going to go 0 minus 2 over 3 minus 3 equals negative 2 over 6 equals negative 1/3. And then I'm going to find the gradient of BC. Now, this time I'm dealing with that one. This one here. And C is here. So I'm going to go 6 minus 0 over 5 minus 3 equals 6 over 2 equals 3. And 3 times negative 1/3 equals negative 1, therefore they are perpendicular. That's good. Okay, what do we got here? So the next question, we have a metal plate that we make by removing a segment from a circle with the center O and a radius 8. Line AB is a quarter of the circle. Blah 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 blah. Okay. Okay, we're gonna find length AB. Well, I guess we could use the cosine rule here. So AB squared equals 8 squared plus 8 squared minus 2 times 8 times 8 times cosine 2.4. Make sure you've set your calculator to radians, and therefore I get, when I square root that whole right hand side, I get 14.9 to 3 SF. Now the perimeter of the plate, I'm going to find this here. So this angle is 2 pi subtract 2.4 radians. So the perimeter is going to be the 14.9, which we've already got, plus, so this bit here is that bit there. And then the next bit is this bit. So it's part of a circle. And it's going to be 2 pi minus 2.4. And it's going to be times by 8, because this is r theta, okay? Remember, in circle geometry, when you want to find the arc length, it's r theta. Now when I chuck this all together, I think it's 46.0. If I can read my writing, I did this a little bit earlier. Okay, now the area of the plate. You can do it in 2 parts. So you can do the area of the triangle, which is half times 8 times 8 times sine 2.4, and this of course is the triangle. That's that bit. And then I want to do this bit here, which of course is an area of a sector, and that is the degrees that it is. 2 pi minus 2.4 degrees. It's all over 2 pi. That's how much of the circle it is. Multiplied by half r squared theta. Hang on a second, what am I doing? Half r squared theta is what we're doing. So half times r squared times theta. So in this case, it would be half times, now r is 8, squared times, now theta is 2 pi minus 2.4. So use those formula that we learnt in the circle chapter, and that comes out to be, I think I got 1.46, sorry, 146 rather, centimeters squared. Okay. Now, the next one we're trying to prove this identity here. I'm going to rewrite the tan to sine x over cos x plus, now this one I'm going to rewrite as cos x over sine x, because that's what 1 over tan x is, and I've got to prove that it equals this other side here. So my first step is to cross multiply, so I get sine squared x plus cos squared x all over cos x sine x, and I hope you can see that that sine x squared plus cos x squared is 1, so we're going to have 1 over sine x cos x, so proved very easily. I hope you're happy with this, because 1 over sine x cos over cosine x, that one's going to go up to the top. Okay, now that we've got that, if we've got 2 of those, that means we've got 2 and I can replace it with tan x plus 1 over tan x, right? And this should be equal to this side of the equation, 1 plus 3 tan x. Now, why did I do it into tan x? Well, because I could see that everything was going to be in tan x. So I'm going to times everything by both sides by tan x, so I get 2 tan squared x plus 2. Because you can imagine if I'm timesing both sides by tan x, it's like 2 tan x, and then I expand the bracket, so I get 2 tan squared x, that one times that one. And if I'm doing 2 tan x times this one, you can see that the tan x's will cross out and leave us with the 2. And then the right hand side, I'm going to have tan x plus 3 tan squared x. Now we'll bring everything across to the right hand side, and we get tan squared x plus tan x minus 2. And I guess we can go, therefore tan x plus 2 into tan x minus 1 equals 0, so tan x equals negative 2 or positive 1. And we can quickly sketch our tan graph. It's a asymptote there. This is 180. We've got another asymptote down here, and we're going up to 360, aren't we? So that's 360 there. Now at negative 2, you're going to get a result here to start off with, and I think that would be, well, it's negative 63.4. So you're going to need to add 180 to get this one. Which is, what the heck is that one? 116. Let me just have a quick look. Negative 63.4 plus 180 is 116.6. So we get x equals 116.6 degrees, and then to get to this one you add 180 again. So that's giving us 296.6, and then we use the 1. Well, this one we know is 45 degrees, so this is this one, and you can see you're going to get another one here which is 45 more than that, so that should be 225, and those are our values there. So solved, and on to the last page of your booklet for this week. I've got a series question. blah 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 blah. Coefficient of x cubed in the expansion. Okay, so to get the x cubed, then you're going to go 5, choose, and you want 3. So you're going to have a to the power of 2 multiplied by x to the power of 3. So that's how you're going to get an x cubed with that one. And then you want to think about how do you get a x cubed with this next one. So it would be 6, choose, now you want 3, which means you're going to have 2 to the power of 3 multiplied by negative x to the power of 3. Now let's, and we know this is going to give us a coefficient of 90. So now 5, choose 3 is 10. So we get 10a squared x cubed. And then plus, now 6, choose 3 is 20. So we're going to go 20 times 8 times negative x cubed. So we get 10a squared x cubed minus 160 x cubed. And we know that the coefficient is 90. Therefore, we know that 10a squared minus 160 equals 90. So 10a squared equals 90 plus 160, which is 250. And so a squared equals 25. So a equals, now plus or minus 5, but it says here it's a positive constant. So 5 is our final answer for that one. Now in the arithmetic progression, the sum of the first n terms denoted by Sn is given by this. Find the first term and the common difference. Okay, well if you go sum of the first term, that'll give you the first term, won't it? Because you've only got one term to add. So it'll be 1 squared plus 8 times 1, which is equal to 9. So therefore your first term is 9. And then we can find the common difference by finding the sum of the second term, and that will be 2 squared plus 8 times 2, and that's 16 plus 4, which is 20. Therefore, to get to the, you've gone 9, comma, and then 11, and you add those to get 20. So the common difference is 2. Okay, that was quite easy. We've got to find dy dx. Okay, so first of all I'm going to write y is equal to 4, and I'm going to rewrite that square root as x to the power of a half, plus, now this square root is like 2x to the power of negative 1/2. Now I want to find the gradient function for this. So I take the power, which is 1/2, I multiply it by the coefficient to get 2, then I drop the power down by 1. Then I take the second one, I multiply that coefficient by the negative 1/2, so I get negative 1. And then I take the x and power and I drop it down by 1, so it's going to be negative 3/2. And that would be my final answer, or we might write it like this, 2 over square root x minus 1 over square root x cubed or something like that, but that'll do. Well, I hope this has been really helpful to you team. Let me know if there's any questions or problems with the video. Take care.